Okay, so there's a question about watching the movie Boy Who Harnessed the Wind, which I have not watched. Kids wondering how windmills actually work and generate energy. Okay, all right, good question. Okay, let's see what the easiest way to explain this is. Um, so, what's kind of happening in a windmill is the reverse of what's happening in an electric car. So an electric car, what you're doing is you're turning electrical and turning energy from a battery, electrical energy, into mechanical motion, turning the wheels of the car around. And it just so happens the way physics is set up, most effects like that, if you can go from electricity to motion, it turns out it's sort of a basic fact of physics that you can reverse things like that. And you can say, let's go from motion to electricity. And that's essentially what's happening in a windmill, is that you're running kind of electric motor in reverse. The wind is turning the sails of the blades of the windmill, and that's running the it's kind of like running the electric car in reverse to go from mechanical motion to electrical energy. Now, if you ask how does the windmill work, why do the blades of the windmill turn around? They actually turn around they're kind of doing the reverse of what the propeller of an airplane would do. So the propeller of an airplane, each propeller blade is shaped so that it will try and push air from the engine of the plane is making the propeller go around, and the propeller blade is shaped so that it will push air backwards. And when the air is pushed backwards, that will cause the airplane to go forwards. That's another one of these sort of physics principles that if you sort of push momentum backwards, it will make you go forwards. So sort of the idea is the windmill is kind of like the propeller of a plane working backwards. In that case, the wind is blowing across the propeller, which is causing, or the blades of the windmill causing them to turn, and then that's causing the sort of reverse electric car to work and making energy. Now, if you ask me why is it the case that how does it actually work to get electric? How does an electric motor work, for example? Okay, that's a little bit tricky. It's a little tricky, and it has to do with features about magnetism and electricity. I would be, if people are interested, I can try and tackle that one. It's a little bit non-trivial because I mean, I can just sort of tell you facts about how electricity and magnetism work, but it's more fun if one can explain why those facts are true. And there's a bit of a stack of physics that you have to explain why those things are true. It all has to do with a thing called electromagnetic induction, which is a phenomenon that, well, okay, so people know about magnets, right? You've seen magnets. How do magnets work? Well, a typical magnet is made of iron, and what happens is inside, so a magnet works, gosh, we have to go a couple of levels here. A magnet works because each little iron atom inside the magnet is acting like its own little tiny magnet. But the question is, how do those things act like tiny magnets? How do you get a magnetic field, magnetism, from anything else? Well, it turns out that when you have an electric current, when you have electricity flowing produces a magnetic field. And what is electricity? Electricity is a flow of electrons. So electrons are these little tiny particles that exist in every atom, but in a metal, which is like a thing like a wire that conducts electricity, it turns out that some of the electrons, usually electrons, are stuck inside atoms. There's a nucleus of an atom with protons and neutrons. There's a sort of electrons going around outside the nucleus. And usually the electrons are just sort of stuck inside the atom. But in a metal, something special happens. There end up being electrons that are not stuck inside atoms. There end up being electrons that are delocalized, that can sort of move through the metal. And so when you have an electric current, what's happening is that electrons, these delocalized electrons, are able to move through the metal. And the electrons, each electron carries a little tiny amount of electric charge. And as those electrons move through the metal, they are producing an electric current. And one of the facts about physics is that when you have an electric current, when you have a moving electron, it produces a magnetic field. So one of the things that you can do is you can have electrons that are moving in a circle. You can have an electric current that's just going around in a circle. So there are these things called solenoids, which are just sort of loops of wire that are turned around many times. A solenoid with a bunch of loops of wire, the electrons are just going around and around and around these loops of wire, and they're producing a magnetic field. And the way it works is a little bit complicated. The magnetic field is at right angles to the direction of the motion of the electrons. And so when you think through the geometry, it means that in this loop of wire, there's a magnetic field that is pointing right out of the loop of wire. So if the loop's going around this way, the magnetic field is pointing that way. So when you, what's actually happening inside the iron is roughly, I'm cheating a little bit, but roughly, the electrons inside the iron atom are kind of going around their nuclei, and they're kind of being like tiny versions of those loops of wire, those electrons going around loops of wire, and they're making a magnetic field, and that's what the individual little magnets that make up the magnetic field from a block of iron, that's what they come from. Okay, so given this fact that an electron that's moving produces a magnetic field, and another fact is that a magnetic field makes an electron move. When you sort of combine those facts together and use a bit of kind of engineering cleverness, you can make that turn into how an electric motor works.